Hi, my name is Mia Heller, and I'm from Warrenton, Virginia. Microplastics are defined as plastic pieces less than 5 millimeters long, and they have been found from the Mariana Trench to Mount Everest. Exposure to microplastics is linked to hormonal disruption, cancer, and to neurodegenerative diseases. The level of microplastics in the human body is rising. In your lifetime, you are expected to ingest 20,000 grams of microplastics. Your brain alone is thought to contain 1 spoonful, that's 7 grams, of microplastic particles. Microplastics enter our water sources through surface runoff, through wastewater effluent, and through plastic plumbing. Traditional water filtration systems were not designed for microplastic pollution, and their limitations make them inaccessible to underserved areas, which, according to a report by the United Nations, are often struck by plastic pollution the hardest. My research focused on using a magnetized oil, called a ferrofluid, to remove microplastics from water. Ferrofluids are highly effective at pollutant removal, but there is currently no practical way to use them for this method. My research focused on finding a way to adapt ferrofluids for use in a water filtration system. First, I designed a low-cost, low-viscosity ferrofluid using a canola oil-based formula, and I tested its effectiveness in microplastic removal. I found that it reduced the amount of microplastics present in water at a significant level. I then used CAD software to design a scalable, self-recycling filter optimized for microplastic removal, with a 2-chamber system, automated mixing arm, and a magnetic drum separator to isolate the components used in the filtration process. I created a physical model of this design with a 3D printer and tested it using the ferrofluid I developed. I found that my device removed 95% of the microplastics from water and recycled 90% of the ferrofluid it used. Results comparable to conventional filtration technologies, but at a lower cost and at a higher efficiency. My project brings an affordable, efficient, and sustainable water filtration system with modern problems at the forefront of its design to the table, and it could bring major improvements to the water qualities of the areas that need accessible filtration the most.